Sub 15 first? The insane moves. Woohoo! How have you been? It's been a minute. Holy crap. Hopefully you've been well. And hey Cook, and hey Joseph. It looks like Joseph wanted that first. No, I mean, you come by as much or as little as you want. There's no obligation. I'm doing good. Yeah, I don't even know if there's anything that's really like that new. There's two like math classes that are being taught on Twitch by other streamers that have been fun to like watch along with. Jeremy got everything under control. Exactly. How have you been, hoo-hoo? Okay, I got the YouTube stream up. And Spetry's here too, yeah. Spetry, wee. Very well, that's awesome to hear. Are you like still on break from art school or what are you doing? Jack. Thank you so much. Hey, Christopher. Everyone, please. I was just hanging out in his chat. Symbolic Logic, aka Jack, is, as far as I know, a relatively new math streamer. Who seems like a super cool dude. So please go check him out. He said he can help with like pre-calc type stuff, Calc 1 and Calc 2-ish, some multivariable differential equations, linear algebra, and abstract algebra is his favorite. So if you're interested in another math streamer, please do check him out. Just us two, I'll take it. I don't mind. Do you want to do intro linear algebra proofs? Oh god, Joseph. I can take a look. I don't know if I can do them. You stopped for real this time? Oh, okay. Do what's best for you. And Iyasu over on YouTube. Best math book you choose if I ask you. Like what type of math? That's a pretty broad question. Oh yeah, we've got Cook around too, or maybe even Jack will know, or someone, or you don't have to help with math if you have to go too, but there should be some around who can figure it out, Joseph. College like engineering. For engineering math, I don't know of a good one for engineering math. I never studied engineering. Maybe like a math book that would like prepare engineers. Ooh, I forgot to do. I knew I was forgetting to do something here. I need to put my phone on the charger because I use my phone for that big cam there. So yeah, I'm sorry, Yas, I don't have a better like suggestion for you, or really a suggestion for you. Oh, you know what? Who's here? And I didn't make my tea in advance, so I'm drinking my tea on stream like I used to do basically every time. Oh yeah, thank you, hoo-hoo. It's definitely shorter. I got cut maybe 2 or 3 weeks ago. And every time I get my haircut, I get reminded that my hairline is receding. Like I'm starting to go bald, like along the sides there especially. But my hair was just getting too long. Joseph, let me know when you post it, unless you, or if you put it in chat, I'll see. If you put the problem in the Discord, just give me a heads up. I think in the meantime, we'll take a look. What are we gonna look at? If you're looking for a textbook, I highly recommend looking at a university you trust in their courses. Some of the bigger universities will post their syllabus, and it should mention the required textbook. Oh, true. That's probably a good call there. Yeah, so if you are still around, the suggestion from Symbolic Logic over in the Twitch chat is try looking at a university and what books they're using, and that'll be a good place to at least start. It doesn't have to be a university you're planning on going to, just like, you know, some big one whose name you know offhand or something. Okay, Yasu is also saying, and sorry, I dual stream to Twitch and YouTube, so Yasu's over in the YouTube chat for anyone who's on Twitch. Okay, one thing you see or you get in studying or teaching math like a core behavior. Like, her lesson the OnlyFans chat? Yeah, true. So yeah, so are you saying, like, what is the reward for studying math, or what do you need to study math? Maybe we'll start the stream with some coding until we have a problem. I keep getting logged out of Project Euler. It's kind of annoying. Common behavior in different topics in math. Common behavior. Oh my god, what is my password for this website? So if you just mean something that you want to like, or if you want to be like well prepared to study math, I think it depends on like what your background is. So I hope this isn't like too far away from what your level is, but like just like your basic algebra fundamentals are really important if you go on to study math at a higher level. So like, you know, being comfortable like solving a quadratic, you know, something like x squared plus 2x plus 1 equals 0. How to manipulate fractions with variables in them, kind of those sorts of basic skills are a pretty big hurdle that I've seen for many students who go on to study like calculus and higher level things. Like, regardless of what you study in math, you should make sure that your fundamentals are strong. I hope I'm interpreting your question right with how I've answered it there. You should probably bring up VS Code. No worries. Thanks for the question. What is a distinct power? Consider all integer combinations of a to the b. You gotta go eat? No worries. Thanks for the raid. And go enjoy your food. All integer combinations a to the b for 2 is less than or equal to a is less than or equal to 5, and 2 is less than or equal to b is less than or equal to 5. They are then placed in numerical order with any repeats removed. We get the following sequence of 15 distinct terms. Where is there a single repeat in all this? How is it possible to, they can never repeat with this. Wait, you get a following sequence of 15 terms. Oh, wait. Oh, 16. Okay, okay, okay. The powers of 2. Oh, right. Okay, okay. Because these aren't prime numbers that we're working with. Okay. That 2, 3, and 5 happen to all be prime, which is what threw me off. But the key to this one seems to be prime numbers. So looking just at the prime numbers, they always generate things that won't be repeats. So we get 4 plus 4 plus 4, 12 terms from the prime number bases. And then only one of these 4 terms get removed. I mean, that's probably small enough you can brute force it, to be honest. I am Iyasu and I am from East Africa. I want to study math, so I download over 30 books. I am engineering student. I feel like I'm good at like Calc 1, 2, 3, and basic mathematics. And now you want more. Oh, nice. Okay, so yeah, you're doing pretty well. Oh, man, I wish I knew some engineering that I could maybe direct you towards more specifically. I'll say in math, that's kind of a branching off point once you know your calculus, where you can study a lot of different things. So at least in the math realm, like you might want to look into like differential equations, linear algebra. What else would like rely heavily on engineering? Numerical methods. Those sorts of things, like I think would be the most directly applicable to engineering. I wonder if we can find you, like if I just bring up MIT engineering. Math discussion or the math help forum, Joseph. So I'm just arbitrarily looking up like MIT because it's a well-known school. Joke from my dad, how are a dollar and the moon similar? They both have 4 quarters. Oh, because there's a quarter moon. Yeah. All right. Nice, Eldritch. Let's get undergraduate. Let's see if we can find do we meet again? All right. See you, Eldritch. That chat emote. Do you have, I mean, I'm not sure if you have a specific type of engineering that you want to go into. I'll just look at mechanical engineering and see if I can find something like in here. Mechanical? Okay, I guess you're right. Class offerings. Here we go. Hey, Scorpra. A chocolate hot dog? Oh my god. Introduction to autonomous underwater vehicles? Wow, that's a first-year introductory subject at MIT. Let's look at like maybe mechanics and materials. That like you can click on those, but nothing happens when you click on them. Okay, let's 2.001. Okay, let me MIT syllabus. Come on. Okay, you posted it, Joseph? I can take a look in a second, unless Cook just is ahead of the game, which is fair too. Where are the syllabi, MIT? It shouldn't be this hard to find. Um, hmm. Okay, I guess this is a little bit more research than I'm able to do right now, but this is the type of thing I would encourage, I guess, you to do, EOS, to see if you can find the syllabus just from some like well-known school that'll probably post it publicly. Maybe MIT don't post their syllabi publicly. Um, but yeah, I would just look up well-known schools and their engineering program and seeing what type of things that they would have you do and see if you can, you know, figure it out on your own. I do want to look at Joseph's question here, though. Yeah, and good luck with your studies, Iyasu. Recall that A dot B is equal to basically multiplying the elements and adding them. Now that this is a really complicated way of writing the definition of these, but it's fine. As for, you know, if you want an arbitrary size vector, show that A dot B, huh? Expand A plus B times A plus B. So, Joseph, you did that. I'm not sure, though, if I was correct to show that c squared equals a squared plus b cubed minus 2ab cosine theta, though. I guess, Joseph, which one of these, do you need help with all these, or like, are you looking at the first one or what? And hey, oh gosh, Plain View. How's it going? Welcome in. I feel like they would want us to use the definitions up here if they're providing them. Some more direct way, especially for 1 and 3. I just want to see if I can, like, at least do this first one in a way that's applying the definition that they provide there. Actually, let me check my T 1 second. Okay, I'm gonna put my mug away and then we'll get to it. Okay. A dot B. As that's a minus. And I just want to see what happens if you do use that, get an actual, like, summation in there. Yeah, Plainview, this is a linear algebra question from Laz Joma there in chat. So A dot B is equal to sigma I equals 1 to n. A sub I times B sub I. Then the magnitude of A plus B is this sigma from I equals 1 to n AI plus BI squared to the 1/2, and then all the way outside of the squared. A sub I squared to the 1/2 squared B sub I squared 1/2 squared. And then this, when the 1/2s and the squares will cancel each other. So you want to go from this to this. Oh, well, I think I see how. I mean, Cook, I know the way is probably cleaner. I feel like you tend to always give the complicated solution that isn't helpful to the student, though. I know, I'm trying to do it in the way that, like, I think they're expected to do it. They're literally given this definition with sigmas, and I think that they're expected to use it. I'm not saying that you're wrong. I'm just saying that I'm trying to teach it the way that, or I'm trying to like solve it the way that you're expected to solve it, even if it's not the best way. Hey, Divya. I mean, where are we given that the magnitude of a plus b squared is equal to a plus b dot a plus b? You're an 11th grade student from India? Oh, nice. Welcome in. How much can we have 2ab and divide by 2? Yeah, David, feel free to put it in chat there or in my Discord, whatever is easier. I'm not sure I understand what you mean by that plain view with having 2ab. Hey, John Doe from Guatemala. Ooh, cool. But yeah, even with my proof, like, where am I going with this? Okay. We want to expand out these parentheses here. So ai plus bi squared is equal to ai squared plus 2ai bi plus b sub I squared. Like that. Okay. And then once we've expanded this out, these summations are all from I equals 1 to n, so we're allowed to basically group them into one big summation. And that's where good things happen for us. So we get a sub I squared plus 2a sub I b sub I plus b sub I squared minus that a sub I squared minus that b sub I squared. And then we get a sub I squared minus a sub I squared, b sub I squared minus b sub I squared. We just end up with 1/2 times, oh, not infinity. I got calculus on the brain. 2a sub I, b sub I. The 2 can come out front to cancel with the 1/2. To get I equals 1 to n, a sub I, b sub I is equal to, don't you know it? Oh, what is that? Oh my god, that's like an onion. It's not even a sigma. There you go. So that's how I would do it. Personally, because I think that's more like how you're expected to do it. Hey, Joel. But if Cook's way makes sense to you and you think you can use it, Joseph, like, also prefer to do it Cook's way. I just don't think it's proper to, like, they literally tell you the things that they want you to use in the sentence before it, and I want to use those things. Did you think, oh, did you, did you do like kind of the same thing, but maybe in a more like roundabout way? Oh, okay. So it distributes like a product. How about this, Cook? I would accept that if we actually showed it using the definition right here. I don't buy just using that property and saying it's obvious, or at least I wouldn't tell a student to do that because they could get marked down for just pulling the property you said out of their ass without, you know, using it or without proving it here. Do I do Olympiad questions? Not really. I'm pretty terrible at Olympiad math. I would give them a warning. Well, I don't even know. Oh, Bob Z Nesbit. Thank you for the follow 6 minutes ago. I'm sorry I missed that. Cook, I'm not saying you're wrong. I'm just trying not to get someone marked down by a picky teacher. That's why I'm saying to do it this way. Like, I think yours needs more justification to not get marked down by a picky teacher. I'm saying this as a matter of like being practical and getting a good grade in the class. I think they would. I disagree, Dr. Cook. But again, like if a cookbook makes sense to Joseph, it's valid too if he wants to use it. But that's the way that I would advise someone. Joel says, I wanted to ask. I feel like I don't know math because of word problems with calculus optimization, also known as maxima and minima. Like I failed to analyze. So what advice can you give me? And sorry, Joseph. I'll go back to this in the next one in just a second. Yeah, I mean, any word problem math is intentionally, or not necessarily intentionally, but they're almost always pretty tricky. You're not alone in feeling like that, Joel. When I see an optimization problem in like your typical calculus class, they usually ask you, you know, to optimize some kind of geometric property like area, perimeter, something like that with a constraint. And the kind of pattern with them is always you take the thing you want to optimize and you take the derivative of it. And then eventually you'll use that like constraint later on in the problem to get a definite answer. Actually, no, I'm sorry. I'm getting the process a little bit wrong. Like the classic problem is like a farmer has 100 feet of fence, and how can they maximize the area that fence covers? And so typically what you do is you write out the formula for area. You know that the perimeter, 2 length plus 2 width equals 100. And you would plug that into your formula for area to you know, get it just in terms of length or just in terms of width, and then you take the derivative. They usually follow a pattern like that. A lot of it is just grinding, and you'll eventually like see the patterns for yourself too. Yeah, I mean, it is notation heavy. I just think that's what the teacher wants. They want a notation heavy answer. Are we doing a college exam overview? These are just linear problems from, I don't know exactly what the context of the problems is. So Joseph, you said on 1 and 3 were the main ones? Oh shoot, you did ask about Olympiad questions, plain view. Yeah, Cook, I I think that's what we have to do here. Sandy, out of most of the people here, the people who are a bit more willing to talk about Olympiad questions, I would warn them it's an Olympiad question, but e to the 2I pi, aka Zach, Penn Center, and maybe n simplex Pachinko, but I'm not sure. I think the other ones might be more willing to look at those types of questions. But I don't know of a person on Twitch who's like super enthusiastic about Olympiad questions. You have a question? Sounds good. Critical. I think we got 1 or 2 more from Joseph, or we got a couple working through from Joseph, and then I can take a look. Looking more directly, especially for 1 and 3. All right, so let's take a look at 3 next. But if you want to talk about third one's all right. Okay. Yeah, sure. Critical. Definitely not Olympiad material. I just find it really interesting. Yeah. There's a couple of other competition enthusiasts who especially frequent Zach's chat, e to the 2I pi. And usually Zach is willing to kind of like struggle with it and like try and attempt those. I'm not. Why is my camera being weird? Fun Math Guy? I haven't heard of Fun Math Guy. All right, Joseph, is there another one on the sheet that you want to talk about then, or? How are you feeling about the rest of these? That's all? Okay. Sounds good. Well, let's move on to criticals then. Oh, going to be an eigenvalue of the invertible matrix A. Oh, we did this one. Yeah. It's like a 2-step proof. We can do it again. Um, Critical might have stepped away, so How's wait until critical's here. This problem, yeah, plain view, it's pretty direct. I want to wait until critical's here before I like doing it before I actually like show it. But you basically take this equation, left multiplied by a inverse, and then divide each side by lambda, and you're done. I'm wondering how we can like do this problem. I think we could brute force this problem. I'm wondering how we can do it efficiently though. So we automatically know that anytime a is prime, we're going to have, you know, the length of the interval for b many distinct numbers in our list. Oh wait, plain view. I'm not sure if it's the linear algebra problem or this problem here. I just realized you might have meant this Euler problem. But yeah, these are like math-based coding problems to this site. It's pretty cool. The number. Okay, yeah. Sorry. So if we have a composite number like 6, that's never going to be covered by a single prime number power. So really, we only need to worry about powers of a single prime. Yeah, plain view. That's kind of like how I'm trying to think about this problem, where the only real issue we run into here is like with 4, 8, 16, and then like 3, 9, 27, 81. I think every other number is fine. Oh, you know what? Wait. No, I might be okay. I was wondering if 4 creates an issue because it's 2 squared. If, say, 36 would make an issue because it's 6 squared, but 36 squared is going to be way out of range of 100. So at least for this exact problem, we don't really have to worry about it, I don't think. What problem was this? 29? 29, got it right. Okay. Wait, what? There we go. We should actually start with the smaller given case and check it with that. And then we can bump up the stuff later. Let me add critical a second time. So for every prime A, we have a distinct number out. No. For each B. Prime, I guess, and composite. And I hope composite means what I think it means. Maybe I should look that up. Composite number. Formed by multiplying 2 smaller positive integers. Ooh. As long as that's what I want. Well, maybe it is. Yeah, I think it implies what I... Well, For the sake of this problem, we would consider 2 times 3 squared as distinct from 2 times 3. Like, those are never going to have any overlap. Except if A can be written as the power of number less than a. Some of its values must be excluded, but some of its higher powers must be included. Let's give an example. Two is less than or equal to a less than or equal to 5, and 2 is less than or equal to b is less than or equal to 5. 4 squared equals 16 must be excluded because 2 to the 4 equals 16. I'm thinking that I want to maybe make like a blacklist of numbers here. Where like as soon as I evaluate 2, I exclude every power of 2 that would cause an issue. So I'd rather not have to store this entire list of numbers as an array. I definitely could. I just am curious if there's a way that I can avoid doing that by keeping good track of just the duplicates, which are presumably a much smaller list compared with the array of numbers that we want to keep. If I was just like trying to get a simple solution, I would just put all these into, I wonder Python. Python does sets, I think. I just like use sets and let Python handle the duplicates for me, but I don't want just like the brute force solution. I mean, I might do the brute force solution to make it up, but I'd like to figure out something that's a little better. Okay, so maybe I'm thinking I want to how does comparing tuples work? I think like maybe I want to exclude 2 to the power of 4, and like I want to store a whole bunch of tuples like that. True. Okay, so this behaves how I would expect it to, or I don't need to do any like fancy thing to compare tuples. So in this small example, we need to know to exclude 2 to the 4. But not 2 to the 5. So I think we care about a non-prime power. Do we only run into issue with non-prime powers then? I think so. I guess in continue else. Now it's where the meat of the loop is going to happen. Oh, you're here? Okay. So we already talked about this question, right? Critical, what was your issue with it? But critical, we already did this question, so I'm wondering, like, what didn't you get? Explain one more time? It's a short one, so I guess. So let's take a hint. So we're going to suppose there's a non-zero x that satisfies that equation there, which is just what the hint says. Since A is invertible, left multiply each side by A inverse to obtain x is equal to A inverse lambda x, or x is equal to lambda A inverse x. Just scalar multiplication commutes as far as I know, so we can do that rewriting. Now divide by lambda. Obtain 1 over lambda x is equal to A inverse x. 1 over lambda x is a scalar multiple of x. Therefore, 1 over lambda is an eigenvalue of A inverse. And I'd say that's what the answer is. Like, that's how I would like write out that proof there. Does that make sense? Critical? I did kind of avoid that. It crossed my mind, Cook. You're probably right. I just wasn't sure if that's something that critical. I don't know if that's something they already had like ready-made, so I kind of avoided it, but you're right. That is a little bit cheesy of me. It's an eigenvalue. And the point that Cook is saying is like right in there. Since A is invertible, I just don't know if you have this fact, so I kind of avoided it because you might not get tested on it anyway, but apparently the fact that since A is invertible, lambda is not 0. It is good to have that in there so you know that you're not dividing by 0, but I just wasn't sure if that was something you already like had in your toolbox. The other one? Oh, a scalar multiple? I don't know, writing too small or it's my bad handwriting, but scalar multiple. Is it an Olympiad problem plain view? Today is your final? Geez. Well, good luck. I guess so, plain view. Here we need to figure out what to exclude. I have this is prime function that I wrote, so it's probably bad, but import helper stop or just helpers? It's not yelling at me for that. But just a little test. Print is prime. Oh wait, I would need to do helpers dot is prime. A star star B. I mean, I guess I know that that answer should be no. Oh, I'm not smart. I'm really not smart. Oh my god. Variable names all over the place. Oh, I B max. Okay, good. And we should have gotten more than 4 falses. Wait, what? Oh my god. There we go. Okay. Now's the tricky part where, well, wait, do I even, I probably don't need to do this incrementing count thing, but I'll do it because it's simple. I think this is the more I think about it, I think it's you could do this with like a pencil and paper. Or I don't know, maybe it's not that simple, but like we could get the total count and then just exclude. Well, there has to be a neat way of excluding the things that we, or like counts the number of things that we want to exclude. So the issue is anytime we have a number to a non-prime power, we need to exclude that until it crosses, or yeah, until the base crosses over the maximum. That's the task here. So maybe I should not even do this. Do this here. And the number of non-prime b's is always the same because we know what the range of b is. I think that's the sneaky way, or the more efficient way. Okay, so this is like pencil and paper, I guess. Bmin, Bmax plus 1. Oh, in Python, do you really type not? I think you do, which is, I kind of hate. How do we get like the raw count that we haven't taken the duplicates out of? It's literally just the number of bases times the number of powers. So we have 4 bases times 4 powers is 16. A max minus A min plus 1 divided by, so A max, B max. No, what? Why am I dividing things? B max minus B min plus 1. So it counts the number of non-prime b's, and the only thing that's left to do I guess we need to count the A's that are perfect squares, cubes, fourths of other numbers. Oh, hey, Pack Bros official over on YouTube. If displacement is 0 in simple harmonic motion, what will be kinetic energy? I don't know that offhand. I assume that's when the displacement is 0, that's when kinetic energy will be at its maximum, and there's no potential energy. Not yet, Plainview. I'm looking at a question from a person over in the YouTube chat. So yeah, Pack Bros, I think with the question, it's gonna be just 1/2 mv squared, I think. Because the potential energy should be 0 when displacement is 0. Apanov taught us, have you ever solved JEE advanced questions? I kind of have. They're very tough though, and I'm not very good at them. Hardest question makes your brain harder? No, those are just... I don't think they're even hard in a helpful way. I think they're just hard in a stupid way. For what I've seen. So I kind of realized that we only need to count... I kind of switched my strategies. I think it'll be more efficient than what I was thinking. What I've done so far is I've gotten the total number of possible combinations, and then I want to pare it down. And I'm trying to figure out how exactly to pare it down. So I figured out we need to count the number of non-prime powers. But I'm trying to figure out how to do this last little bit here. So I think the number of I guess we want to count the number of A's that are, or like I was thinking we want to count the number of A's that are perfect, that are powers of another number. But doing that is kind of annoying. And I wonder if there's a better way. Okay. Maybe instead of counting, I want to track these in a list. Can I append? How do you... I just want to append an item to a list. How do you do that in Python? Oh, I'm doing it's square brackets, not curly braces. There we go. Dot append. And so now what we want to do is we want to this is annoying. We want to, for every A, we want to check if A to the, like, I want to check every factor of these non-prime numbers, not including, well, do I include one? I guess I do. Yeah. What am I could do? Okay, so it does give me all the factors like I would think it would. A max plus 1. We want to check if this thing would have been caught earlier, I think. And I'm trying to figure out exactly how to express that. Oh, I'm sorry, Plain V, if you want to talk about a geometry problem, feel free to just like put it in chat and I'll take a look. Because it might take me a little bit to figure this out. What's happening here? Actually, no, I don't want to detect 4 to the 1. I want to detect 2 squared, right? Okay, I'm back to doing a double for loop, which I thought I might have been able to avoid. Assuming the cube has side length of A, find the volume of the cube instead of points that are closer to the center of the cube instead of the corners of the cube. Express that volume in terms of a cubed. Oh. The volume of the set of points. So we need to figure out what the set of points are. Oh, in terms of like the length, the side length A cubed. Okay. I'm getting like sphere vibes. That's more of an instinct thing though. No? Well, okay, where would the... Where were the centers of the faces? MEPS tomorrow. I'm not sure that is correct, but whatever it is, I wish you luck. Is that Marine's thing? The medical check. Ooh, nice. Yeah. Good luck. I hope it goes well. Take a break from this practical Euler problem. So we gotta, I guess, start by getting our heads around what this thing is going to look like. So yeah, it probably isn't going to be a sphere. I could see it being like a diamond. Maybe. Terrible cube. Oh my god, it doesn't even connect. Okay, let's give it one more try. Start just by drawing a square. Draw another square. Slightly better cube. So where does like the exact center of a face get mapped to? To the actual center of the cube, it's a over 2. To any of the corners, it's square root 1/4 a squared plus 1/4 a squared, which is root 2 over 2a. So it's closer to the center of the cube than it is to the corner. So the centers of the faces are going to be included in this volume. Things go in about a month, you're getting screamed at. No, I'm not saying it's a sphere anymore. Oh wait, you're saying that to Cook. Hey, Anders. So we broke it down into the 8 corners of the cube. Yeah, I mean, it is symmetric. We could look just at a corner of the cube. That might be helpful. Try the question in 2D. That's probably even more helpful. What is the locus of points that are closer to the center of this square than to the corners? Or, just the set of all points. Because this is going to be relevant for how the faces of the cube get mapped, I imagine. If you know the faces of the cube map, you can probably fill in the blanks between them. It'll be like indicative. So definitely the centers of each, like the north, south, east, west lines are going to get included in this area now we're talking about. Like less distance, Anders, I think. Like minimizing the distance. Thing on one of the corners closer to the corresponding corner. I feel like we need a triangle in here. Like, at what point does this stop? So, like, definitely, if this is the point of interest here, I guess I'm trying to imagine sliding this point to the left. Oh, wait. No, this is equal in the 2D case. These are both a over 2. So as soon as it goes slightly left, we're closer to the corner. So I think on the borders of this square, we only have these very points that are potentially included, although they're exactly equal. They should be a transition point. Oh, I think they mean on or inside the cube. I'm only thinking about on the cube for now, just to try to make the borders of this thing, but the borders might be inside the cube, and this is going to be the wrong approach. Sure, you can whisper the answer if you want. I won't look at it quite yet, but... So I think don't we just get the straight lines and... Like, we just get a diamond like that, don't we, for... the 2D case? And so after I said sphere, I was thinking that it could be, if I can actually draw it. It could be like a diamond shape with each one of its vertices at the center. Like, it's probably not the right perspective there, but like the kind of diamond that would be contained in that, or I guess really a cube that's rotated. So its center is the same, but the corners of this cube are at the centers of the bigger cube. Yeah, it wouldn't be an octahedron. Well, wait. What did I draw? That is an octahedron. What I drew. Really? Are you sure that's what they mean? To me, what they mean is, like, I never had a question about the wording of this. I mean, it would still just be, yeah, correct. Like, it would still just be a cube, just not in the same orientation as the bigger cube. But well, the thing that I drew on screen, or on the right side, is that a cube? A cube has 6 corners. No, a cube has 8 corners in 6 faces. The thing that I drew has a corner on each face, so therefore it has 6 corners. Which would make it a triangular pyramid on top of another, or like, you know, whatever that shape is called, a triangular pyramid with another triangular pyramid on top. With 6 total faces. No? Yes. Hexahedron? Thank you, Obi. You can slice the octahedron, translate the halves to form a cube. The cube and octahedron are dual to each other? Octahedron. I am thinking too complicated. Yeah, I can definitely see why it wouldn't be an octahedron. But I feel like it should just be a hexahedron. Where each of these corners is at the center of the face of the cube. I don't know what duality means in this, like, context. Projective geometry? Maybe that link will be better. What do diagonals have to do with it? They're perpendicular to diagonals. But that perpendicular to diagonals thing leads me to a hexahedron. Oh, okay, so that's the exact thing that I didn't know this term existed, but that's exactly what I was saying with trying to construct the shape inside of that cube. It leads to an octahedron. A cube has 6 faces. What? It can't be an octahedron. A cube has 6 faces. If you take the middle of each of those faces, you get 6 vertices. It has 6. An octahedron has 6 vertices? One, two, three, four. What the fuck? Okay, fine. It's because it's sharing, okay. But doesn't this... I already hate geometry. 3D geometry is even worse. Where the hell does this square in the middle go? Or like, how does this make sense? Oh wait, okay, I see how, wait, do I see how it makes sense? No, I hate geometry, plain view. I don't enjoy it. I think my drawing is like, oh my god, dude, I see it now. It's because my drawing sucks. Yeah, I can visualize it now. Does GeoGebra? Oh, I shouldn't bring up GeoGebra. I'm gonna rage at it. But doesn't it, or don't they do 3D now? Maybe. Start calculator. 3D. Okay. I didn't actually do like, or I know this isn't like the there's more to the problem than just this, but I want to wrap my head around this shape. Oh, do you have a pre-made thing? That would be great. There we go. That's what I tried to draw on the whiteboard that I didn't really get right. And so what's the volume of an octahedron? Root 2/3 a cubed, and we just need to figure out the side length of this thing with respect to capital A. So we want from the center of one face to the center of the other face. That's just a over 2 and a over 2, right? Yeah. So it's still root 2 over 2a, funny enough. No. Yes? Yes. Okay. I think it's root 2 over 2a. So what we have is root 2 over 3 times root 2 over 2a cubed. One six a cubed? Oh, it's a cubed over 2 apparently? Why am I getting the wrong answer? What? It has something to do with it. I thought we said it had, it's, what? I thought we said the answer is an octahedron. Innate Tartar, I see you too. It looks like the Twitch chat is going in a different direction of the problem. There might be a polar idea there too, but I don't know it. Well, okay, correct. In that case, you're cutting the cube like diagonally in half? Like it's basically going to be a triangular pyramid? And so in each of the 8 corners, you have a everything one of the 8 corners is a cube. Yeah, right, correct. But I'm getting right back to an octahedron. Like, so you're saying like we're splitting up into 8 smaller cubes and looking just at like like say that point down there is the center of the bigger cube. But I think the solution for the set of points that are closer to this point than they are to that point up there, like you cut it across the 2 like, or I guess even the 4 other vertices that aren't involved, and you end up with, you know, a square base pyramid. Right? Wait, no. What? Why can't I visualize this? It's a... What is that shape supposed to be? Like, I imagine you're cutting the cube diagonally in half. I must be drawing it wrong again. I don't know, dude. Oh god, Terrat, are you doing it with calculus? That looks like it's gonna be a big pain. Honestly, playing the, yeah, just link the solution. I'm getting a little bit done with this problem. I just can't visualize it. Oh, what is a triangular pyramid? Okay, I did fit. Okay, I can find at least. If you take that smaller subcube that Corrupt is using, and this is like the center of the big cube, you're interested in the triangular pyramid that connects these 3, or I guess these 4 points. Doesn't that lead you to an octahedron though? Like I don't know how it's not an octahedron, I guess. I think I can visualize the little 1/8 of the cube now. But if you reflect it around 8 times, you get 8 faces. And that's an octahedron. Also, I'm still not doing it right, which is probably a reasonable guess. Yeah, that's a weird name, but what are these drawings? Central here yet? No, Hargi. I'm not going to watch a 12-minute video to figure out what's actually happening with this solution. Oh, what the hell? Okay. I get it. You're taking only one half. You're taking half of those little subcubes. And that just implies, and that just, by that symmetry, it's going to be half the entire thing. Okay. There's central. Okay, so this line of reasoning makes sense to me. I still don't know. I guess it can't form an octahedron then, I guess. It really seems like it should form an octahedron, but I guess it just doesn't. And I'm kind of done with this problem, so I don't really want to figure out why it's not an octahedron. Hey, Waffle. Thank you, Plainview, but I don't want another geometry problem. I'm sorry. I don't. Hey, Krish. I'm good. How about you? I'm sorry. I don't enjoy geometry. I'll do it if someone needs help with a geometry problem, or if it's slow and like someone really wants to talk about it. But I really don't want to do it all the time. Really just for fun. Oh, thank you, Corrupt. It's a much easier problem to work on. Hardest area in math, no pun intended. Oh, what the hell? Oh, you know, this might be what Territar was doing over in the YouTube chat. that's the solid that it forms? So it's 8 octagons plus 6 squares, or hexagons. I can count. Thanks for the follow, plain view. An octahedron that has been trimmed. Yeah, you're right. I think, oh, it shrunk a bit? Okay. I definitely prefer the like 2-line argument that's like each of the little 8 subsquares are cut in half, so the entire thing is just cut in half, but trying to visualize this is a little too hard for me. And like I enjoy trying to visualize like multivariable calculus problems. I just can't do this geometry stuff. But yeah, Brian, that's a problem that we were just working on. That it's from plain view. And so Cook like use Mathematica to get the actual shape of what's happening in that problem. Hey, S-tier programmer, it's going good. How about you? The diagonals of the cube are halved and the diagonal halves are perpendicularly bisected. Okay. Good to hear. So what I was working on before, I could definitely brute force this project or the problem, but I want to find a neater way of doing it that would work for like, you know, a stupidly big range of numbers. And I think what I figured out is that we're really running into issues with non-prime powers, because you could rewrite, say, 2 to the 4 as 4 to the 2, and those are equal. And so I'm trying to exclude those cases, but figuring out like how to count them is a little bit tricky, because it's an example with like between 2 and 5. What's with this between? We don't want to exclude, say, 5 to the 4, because we will never get down to 25 squared. Oh, thanks, at S-tier programmer. So yeah, the theme of the stream for you or anyone who's new is I do like a math homework help. I dual stream to Twitch and YouTube. The Twitch chat is up there. I can't put the YouTube chat up there mixed in because of the stupid Twitch policy. And in the meantime, if there isn't a question from chat, I will kind of do some self-studying. So right now I'm working on a project where the problem is to try and learn or relearn to code. But I've also been studying like abstract algebra and studying electricity and magnetism too. So I think really all that needs to happen here is I have this list of non-prime powers, and I really just need to check how many of those a to the power of each factor are in the range of a. Hey, Federico. You're working on Project Euler as well? Oh, nice. Hope you're doing well. Am I having a good day, Don? Yeah? Nothing catastrophic has happened, anyway. Am I a mathematician or a CS grad? So I have a bachelor's. I majored in applied math and minored in computer science. I graduated a good... what year did I graduate? I don't remember what year I graduated. If I'm 27 now and I graduated when I'm 21. 6 years ago. That's how that math works. So I graduated when yeah. So the programming especially I've forgotten a lot of the math that I was doing too. Oh. Okay, well, thank you, S-tier programmer. I'm so close to... I'm nearly at picking this up. Oh, hey, Xantospa? I'm probably pronouncing that wrong. And lightning speed and nothing. Welcome in, everyone. Thank you, S-tier program, for spreading the word there. I guess for all of you who are new, I'm Don. The thing with stream is I do like math homework help, and when things are slow, I will kind of do project or the problems like I have on the screen right now, or I'll study some topic that I'm interested in. So the thing I'm coding right now, the problem is right above me. It's from project.euler.net. .net, yeah. And I dual stream to Twitch and YouTube. So the Twitch chat is up there, but I can't display the YouTube chat. And my day's going well, Lightning Speed and Redhead. How about you all? Get him 600? Oh, thank you. What even am I at for the YouTube sub count? $591? Oh yeah, up to 593 now. Thank you guys so much. I started streaming on YouTube, or I didn't do a single thing on YouTube until a year after I streamed on Twitch for a year. And then I started doing things on YouTube at all. And slowly the YouTube sub count is catching up to the Twitch follower count, which is awesome. So at Twitch, I just got over 900 followers. You'll donate $5 if you play Skibbity Toilet video. Try like $5,000. I haven't watched Skibbity Toilet and I don't want to watch it. Twitch, I'm currently at 908 followers, which is like the equivalent. I don't know what Skibbity Toilet actually is, but I just know it's something that I probably don't want to watch. Do I play games? I do play games, but I don't. I have a separate gaming channel for YouTube where I post some videos to, but I only stream the games on Twitch because it's really annoying to stream to two different YouTube channels, and I'd rather not stream games to this math YouTube channel. Okay, S tier programmer. So yeah, Redhead, there's no problem that's like too, I guess like a I don't want to say like low level, but you know, there's no problem that's like too easy for me. If you're in 8th grade and you have a problem, please do let me know and I'll happily work it out. I often like help out people with like calculus and stuff too that you might be learning later on, but if you're doing 8th grade math and you need help, I'll definitely help. You're a freshman? Oh, nice. Lightning speed. It's 1 + 1. I always thought it was 3, 2. You were close though. You know, I think that I'd be partial credit on the test. Yeah, I do have a Discord server. Oh yeah, Italian. We can definitely do that problem. I'm actually working on theory in math, but you're scared to publish it. I don't know why. I'm scared of it being wrong. Yeah, I have in California, Plainview. Well, that's cool, S tier programmer. I guess I mean, I think if you actually like sending it to a journal, I think they'll kind of tell you in peer review if it's wrong. But yeah, I mean, I've never published anything for myself, so I guess I can't say that I know the feeling. I do actually have my name on an academic paper, but I was just a research assistant, and I didn't actually have a. I was going to help collect the data, and that was my entire role in the project. So I didn't have to deal with like the publishing process or anything like that, or deciding like whether it was correct or not. So Italian 978 asks if A equals 7 and C equals 21. What is A squared times C squared times A? Hard luck, thank you for the 69 bits. Okay, so there's a couple ways that you can go about this. I would probably just kind of plug things into this template they give you here. So we know that A is 7. So we have 7 squared times C squared, C is 21, and then times A again, which is 7. So squared just means you multiply the number by itself. So we could also write this problem as 7 squared is 7 times 7 times, that times, 21 squared is 21 times 21 times 7. And this is going to be a big number that will be kind of annoying to calculate by hand, but we can do it. Do I have any tips going into uni? Yeah, I'll talk about it a little more after this plain view. Yeah, there's a couple ways you can go about calculating this. If you're allowed to use a calculator, that'd be fantastic. And there is like a little trick we use to maybe make it a little bit easier, but honestly, I think I'd rather just keep things simple because I'm not sure how comfortable you are with this like sort of arithmetic. Kind of like the brute force way that like is direct and will always work is just go from left to right and work out each multiplication one by one. So 7 times 7 is 49, and then the rest of the problem hasn't changed. Then we do 49 times 21, which ideally you can use a calculator, but you can also just do it out by hand if you know how to do two-digit multiplication. 9, 2, 1, 10, 29 times 21 times 7. Now we're worried about 10, 29 times 21. 9, 2, 0, 1, add a 0. 18, carry the 1, 5, 0, 2. Add them together, 9, 0, 1, 6, 1, 2. And sorry, I'm kind of blazing past the part because if you're not comfortable with doing this, I can slow down and explain it more. But I'm making the assumption that you're maybe okay with how to multiply numbers, and it's more about plugging things in for A and C and working with deciding like what math to do one. 21,609 times 7. Now we have one last math problem to do, and then we're done. 21,609 times 7. Let me actually check chat before I... Let's talk about the Riemann hypothesis in depth. I don't have anything to say about the Riemann hypothesis. Oh. So wait, Italian, you already know the answer to this question? I'll say that I prefer to work on questions that people like need help with. Don't just like test me for fun, please. But that's like the basic way you go about solving this. But yeah, you could split up into 7 to the 5th times 3 squared. You still have a bunch of math to do there, though. Calculators exist? Oh, okay. Hey, JC2407. Welcome in. Derive the quintic formula? You mean the one that can't exist? How many times do I get asked about the Riemann hypothesis every day? I guess for each math stream, I probably get asked every other math stream, so maybe like half the time each day. It's a really common like joke. Oh, it's Dr. Cook. No worries, Federico. Okay, so Plainview asks, do you have any tips going into uni? So what stage are you at, Plainview? Are you applying? Have you already applied and you have to choose? Have you already chosen and you're trying to figure out a major, or like where are you at, Plainview? Am I solving the Riemann hypothesis? Oh, hey, we're bringing the average up now, Tertar. It's twice in one stream now. I will solve it on Saturday. I won't tell you which Saturday, but I'll solve it on Saturday. Some sodium, metal, and okay, Italian. I don't know what that really means or does. You're interested in complex analysis. Oh, cool. Over on Twitch, as a streamer named Penson who's actually doing a complex variables class. And it's a really cool thing where some students there are actually taking it for like credit, but you're also allowed to just take it for fun too. So it's been really cool to like follow along things. It's a real like college course being taught on Twitch. 11 class, we have 13 classes here in Germany. I don't know what that means, Plainview. Like, do you know what university you're going to? Do you know what major you're going to be? Like, I don't know what 11 class means. Oh, you're in 11th grade, maybe? Yeah, let me, I can, there's a whole list of people on Twitch who I like generally recommend for math things. For the complex variables class, oh shoot, I think the last class is tonight. It's a 6-week class, and this might be the last one tonight in 2.5 hours on Penn Center stream. It's kind of early for me because I'm in 8th grade, still learning. Wow. Well, you're ahead of the program then. S tier, nice. 7th grade, Pershing C's in math. So yeah, I'll say over on Twitch, there's a whole community of like math streamers who kind of do a similar thing as me. On YouTube, I haven't really found anyone who does it consistently, which is unfortunate. But actually, I guess I'll see if I can get the list copy pasted over to YouTube. If anyone does know Twitch and go on it, here's a whole bunch of people who stream math help on Twitch. Or like do math help in general. So Plainview, you're in 11th grade and you have 2 more grades to go before you would go to university. So I'm going to assume that you're in the phase of figuring out what university you want to go to. And maybe there's some kind of standardized test that you're going to have to study for as well. Feel free to post it critical. 597? Oh, awesome. Oh, you already know. Okay, which one you're going to? Do you know what you're going to study yet, Plainview? Bringing up Critical's question right now. Finish the chapter, you have to... I don't know how to pronounce it, but Thevenin's theorem? That's where I'm at, too. It's good to hear. $10. Your brother went to Harvard, you want to follow his footsteps. Do you have any tips on succeeding in math? Have really good fundamentals. It'll help you. It'll save you when you're taking a calculus class. Like, don't just not pay attention in an algebra class, because that stuff does come back to bite you when you take higher level math classes. This is the biggest thing that I see with students that I've tutored. Thevenin's theorem is a theorem in physics for it basically says that for any circuit with like two terminals where you would connect to it, you can think of that circuit as just like a black box with a voltage source and a single voltage source and a single resistor. So it lets you like simplify a circuit and think about it and not have to worry about like the intricacies of the actual circuit when all you're doing is plugging something into each end. You're studying computer science. So yeah, I guess I would say like socially, just be open to doing new things and meeting new people, and even if you have a bad first impression of someone, just like, you know, let go of it. Academically, not necessarily like something to study, but like, at least at least how it works in America, I would never buy my books until after the first day of class, because books are incredibly expensive and a lot of professors don't actually require that you have them, but it's hard to know until the first day of class, and they don't usually expect you to have it on the first day of class. So if it's anything like that for you, don't buy the textbook until after, because you might not actually need it. And you can also, I've heard that there's places that may not be, well, let's just say there's many places to find textbooks that may be less expensive. You have a video suggestion? I don't really watch videos on stream, but if you want, you can post it in Discord or something, and I'll take a look at it another time. Hey, Timothy Miglin. All right, so let's look at criticals. The matrix A is factored in the form PDP inverse. Use the diagonalization theorem to find the eigenvalues of A and a basis for each eigenspace. Well, this middle matrix are the eigenvalues, are they not? And a basis for each eigenspace. PDP inverse. So over here on the left are our eigenvectors. Oh, that's not what I wanted to do. So we'd have a repeated eigenvalue here. For lambda equals 3, we want to take the first. So these first two columns here have the 3's in them. So we're going to take the first two columns from the P matrix, I think is how this works, and do a linear combination of them because they're asking for the eigenspace. So 2, 1, 1. times, I guess we can call the constant C1. It's not particularly important what it's called. Plus C2 times the other middle column, -1, -1, 0. And then, so that's the eigenspace for lambda equals 3. For lambda equals 4, it's probably bad form. Yeah, I guess I'll do C3. I don't know if it's really all that important, but times the last vector in that P matrix, -2, -1, 0. So these are the eigenspaces associated with each eigenvalue. Is my understanding? What's in that Discord server, Lightning? It's my chill out server? Okay, well, I'm already in a lot of servers. I don't want to be in another one. I'm sorry. Aniket, how to subtract O minus 0? I'm not sure I understand what you're saying there. But if you have something minus 0, it's just whatever that thing was. One second, critical. I'm getting this thing into Paint so I can mark it up. Okay, so I didn't want to copy down all these matrices just to make this point, but it's because simplicity is repeated. Okay, so these are the eigenvalues here, as we said. Oh, I mean, I thought the word is multiplicity. Simplicity might mean that too? I haven't heard of the term simplicity before. It might be right, and I just don't know it. Okay. But yeah, it's because of the multiplicity of 3. So the first column here has lambda equals 3. And the first column here corresponds with the first column here. And then we go to the second column. We notice we get a 3 again. And it goes with the middle column here. So because we get the 3 twice... Oh, okay, Plainview. Thanks for hanging out. Because we get the 3 twice, we have to take a linear combination of everything involving 3. So if we had multiple 4s, we do the same thing for the columns with 4. Now you get it? Okay, awesome. No worries. Can we do an IMO problem after this? I don't like IMO problems. I'm sorry. Does minus infinity equal plus infinity? No. One represents arbitrarily large positive numbers, the other represents arbitrarily large negative numbers. Doesn't the Riemann sphere prove it otherwise? Like for complex numbers? Complex numbers are different because there's not really a notion of negative infinity for complex numbers. Usually you would say as the magnitude of a complex number goes to positive infinity for getting infinitely far away from the origin, but there's not really... You can't really have a complex number approach negative infinity, to my understanding. Like, it doesn't make sense. Now I want to cycle, I guess I want to cycle through this list of factors, but what am I going to check for? And when I cycle through this list of factors, do I care about the first power or the last power? Meaning, like, if I have 6, or if I have, like, factors of 6, do I care about 6 to the 1 and 6 to the 6? Oh, wait, I don't have that. I have... Those are the exponents. I think I want only... I want to skip over to the first power, and I want to skip over the last power. Is it safe to post your work on ArcSiv? I mean, ArcSiv is like a reputable site, if that's what you mean, and if you are thinking about someone like stealing your idea, I think that will be proof that you had the idea first. I don't really know how that kind of, the whole world of like academic publishing like that actually works though. Woke J66, thank you for the follow. So what I want to do with this loop is catch, if I have 2 to the 4th, I want to say, hey, that's the same thing as 4 to the 2, and subtract 1 from the count. The problem I'm working on is the one that's right up there, S tier programmer. In my program, what I'm trying to do is I'm trying to do it in a clever way that's not just brute force, although brute force wouldn't be too hard here. Or it'd be really easy to do it a brute force way, but I'm getting the total number of combinations, and then I want to subtract. I want to be able to like find the pattern for when a repeat is going to happen. No, well, Jay, please go ahead and ask your question. This is just a filler thing that I do while I always see someone in chat ask a question. You can type it out there in chat, or you can put it in my Discord if that's easier. Yeah, sure. Okay, so I think we want if I to the power of f is less than or equal to a max, and j divided by f is less than or equal to b max. We want to do distinct nums minus equal 1. I'm not really sure, but let's test it on this case and see if it does get 15. I feel like I maybe there should be a more efficient way to do it than this, I feel like. But let's test it on the big. It works for the small case. Let's test it against the big case. So we tested it on 2 to 5, but there's only one duplicate between 2 and 5 that we have to throw out. Between 2 and 100, 9182? Let's just try it and see if it works. And regardless, we'll switch over to woke J's problem after this. $91.82. Oh, no. Damn. Okay. 95 watch streak? Nothing to say. Oh, okay, we'll keep trying with this one later. I see WoJ posted their problem, and then Karam over in the YouTube chat. What's more difficult than non-homogeneous higher order differential equation? I mean, harder depends on the person, but what you probably study after that are partial differential equations and systems of differential equations. You haven't worked on those already. All right, so WokeJ66, trying to write a program that controls LED brightness. I want to start with min brightness, then over some duration in milliseconds, I want to increase the light value to max value. After reaching max value, I want it to go to min value again, and so on. I don't know how to calculate the light brightness of for current frame. Example, min value 0.2f, max value 0.8f, duration 800 milliseconds. You want to calculate the brightness of the light after 1500 milliseconds. Okay. So you want some sort of periodic function. Ooh, I bet there's a really clever programmer solution for this. But like, since I'm more of a math person, I would say to use like sine. But sine follows a curve, and you might prefer like a linear, which actually we can probably figure that out too. Do you have a preference on like how it scales? Like, do you want it to scale linearly? It might not be that noticeable duration. I think that making it linear wouldn't be so hard, and we could at least start with that and talk about other possible solutions too. How would we want to do this? So I guess what you could do we could figure out the equation for a function time and I guess brightness, but I'll call B. So your example min values are 0.2f and duration 800 milliseconds. Okay, so we're starting at the time t equals 0, brightness 0.2f, and you want the total duration to be 800, but over that 800 milliseconds, you want it to peak and then come back down. So I'm going to cut that in half and say at 400 seconds, or sorry, milliseconds, we're going to have our peak, and then at 800 milliseconds, we return to our baseline. So it's going to be like approximate, like my scaling, because that's not the important part here. Sorry, I shouldn't. This will be 0.8f. So if we just want a line, we would go linearly from our starting point up here at 400 milliseconds and then return back down to 0.2 at 800 ms. And you can take the same triangle wave and basically make it periodic, like repeat it every 800 milliseconds. Okay. We can adjust that. So the entire period is, we would call it 1600. Or like the period would be 1600 because that's like one full pattern of this. That's fine. So what we can do, we could call our function b of t and make it like a piecewise function. I'm expressing this in the math way because that's what I know, but we could also program this without too much difficulty, I think. So the first part of our function will be this like positive slope line. So you remember like y equals mx plus b. B is the y-intercept and m is the slope, which is y2 minus y1 over x2 minus x1, or rise over run. So to get y equals mx plus b, or in case we have b equals mt plus, oh, that's that's a poor use of b on my part, but you know, so instead of y and x, we have t and b with what I did, but these are just letters. We can make them whatever we want. The point up here is 800.8f. This is 1600. Oh God. .2f. So yeah, for this positive slope, we're going to take this as our x2, like x2, y2, and this is our x1, y1. So 0.8 minus 0.2. I'm going to drop the f's here just to clean it up a little bit. 800 minus 0. That you can plug into calculator, but it's 0.6 over 800. Oh, I'm sorry, I didn't write the rest of the line. Times time plus the y-intercept of 0.2. And then we can simplify this part. What's 0.6 divided by 800? You're probably right, Jed. I think it might be a little bit too much in the, or that might be like more like math than we need for this like programming problem. 0.6 over 800 is 0.00075. Plus 0.2. And this is valid. I'm running out of room on the whiteboard because I started way too far to the right. But it's valid for 0 is less than or equal to t is less than or equal to 800. And then we can do the same thing for this negative part of the line. So now this point is x2, y2, and this point is x1, y1. This one's a little bit more annoying because the y-intercept isn't just given to us. So I'm actually going to work it out separately down here. And say b is equal to m, we can plug into the formula. 0.2 minus 0.8 over 1600 minus 800 times time plus the y-intercept, I'll say y sub 0. That's just minus 0.6 over 800. So it's just negative 0.0075, which is actually, that's expected. And now we can figure out what that y sub 0 is by plugging in either of these points and solving for y sub 0. So I'll take that point, because why not? The brightness is 0.8. The time is 800 plus y sub 0. That we can plug into Wolfram alpha. Because I don't feel like doing 0.0075 times 800. Like subs on Twitch, I have 22. Subs on YouTube, I'm close to 600. 1.4. Okay, so for the other part of our piecewise function here, we get minus 0.00075t plus 1.4 for 800 is less than t is less than 1600. So these are the two things that you could like, I'll just use like, if you're programming this, I would just use like, have a function to represent this b of t, and just use an if then to figure out which part. Well, I'm sorry. There's an extra step that you said, which is you want to figure out, say after 1500. So for 1500, that's already inside the bounds of what we've defined this thing to be. So if we gave it 1500, we can use an if then to go on to this part of the function and just evaluate that. But if you were given, say, you want to figure out what b of 5000 is, what you would do is, because we're saying this thing is periodic with period 1600, you can just repeatedly subtract 1600 until you get something that's between 0 and 1600, and then plug into this formula. So you could do that with like a while loop right there. 3400. And then we could subtract 1600 again. Or mod it. Oh, you're right, Jed. This is, yeah, I'm doing a budget modulus. So yeah, you can take 5000 mod 1600, and 1600 goes into 4800. So this is the same thing as b of 200. Okay. Mod won't create a continuous function. Oh, really, Territar? Oh, shoot, I'm sorry, I forgot that I was writing like underneath the problem. Oh, Brian, I can bring that up in a second. I don't have it active right now because it wasn't working before. So WokeJJ, or sorry, WokeJ, I hope I'm pronouncing that right. I'm giving like the very math-centered explanation here, but since it sounds like more of a coding problem, I can quickly like type out in Python what this thing would like look like here. Like you could define a function for like a brightness at time t. And say that time equals t. So like I don't imagine it's gonna be a problem with mod. because we're only modding the input. In Python, do we mod with a percent? I hope we do. And then now if time is you probably, if time is less than or equal to 800, you might need to be a little bit more cautious here with like a negative input if you, I'm not sure if like a negative input would work, for instance. It probably would still work, I think, because mod will just take care of it, but it's something to like check. You'd want to return, if it's less than or equal to 800, we're returning our top function, which was 0.00075 times time plus 0.2. Else return minus 0.075 times time plus 1.4. And I think that's the entire function that you would, or yeah, all that math, but I think it would just come down to a function as short as this, in Python at least. But we don't have to do this with like a line. We could also make a sine function work, or kind of like anything periodic. Or Jed has an idea. Min, max, and period as input parameters. Okay, so yeah, I guess you and Jed are getting the same thing now, Wilk, where if we want to make this arbitrary, yeah, we can take this as like a template and modify it to be like an arbitrary thing. So we can make it like for time, if I do this, nope. I hate that Python doesn't have block comments. It's so lame. Okay. Let's do def brightness. Min, max, period, and time to evaluate it at. How about that? Triple single quotes before and after. Oh, I think I have seen that trick because it puts it into one big string and then you can comment it out. Or even it's just a string, right? Okay, okay. It's kind of cheesy because it's not actually a comment. I think that Python is still going to try to do something with that, but Teratar is that might get the right output value, Teratar. I don't quite know like what to make of it. I would have a hard time explaining it. I'll put it up there on screen if someone wants to look at it, but I'm just trying to do this like I guess, an intuitive way. So put if false. Oh, true. Yeah. I really hate that, but yeah, it would work. Oh, maybe. maybe, no, I still don't quite see what that's doing, Territar. So we can define like the peak as the min minus, or the max minus the min divided by 2. Paste it into Desmos. I guess I'd never really explained like how to come up with that though. So I'm sorry, we want the average of, wait, no. Sorry, okay. I want to use something slightly different here, which is instead of y equals mx plus b, there's something called the point slope form of a line, x minus x0. So we can add the y sub 0 over. And I think that's the form that I want to use, because it'll be a little bit easier to do with arbitrary things here. Does mod do fractions? I have no clue. So we want to do let's take the time mod the period again. And so the period here is from min to max and back to min. So it's the full like rise and fall, not just the rise. And I guess maybe we should note that this function is going to peak occurs at time period divided by 2. So if the time is less than or equal to period divided by 2, this is the first case of the function that we dealt with up here. I'm just trying to translate this into like arbitrary variables here. And so here I'm going to do point slope form of a line, y equals mx minus x0 plus y0. So first let's calculate the m. So this is peak minus, or sorry, not max minus the min, because that's the y2 minus y1, divided by x2 minus x1, which is just the period in half. I'll just say since we're going to use it a few times, 2.0. Excuse me. So this first chunk here is m. Now we're going to multiply by x minus x0. And x is input time. So time minus, we can use with x0 equals 0, y0 equals min. so since x0 is 0, this x minus x0 is just the time, and then plus min. You have to go? All right, see ya, S-tier programmer. Thanks again. Also do the integral of floor of sine omega t? That's interesting to know. I'm trying to like keep it simple, I guess, but y sub 0 equal max. So here we have min minus max over peak time times time minus peak time plus max. Sure, German sub TV. Feel free to type it out there in chat or put it in my Discord. Whatever's easier for you. Oh, okay. I should have done that a while ago. All right, so Woke J, there might be a simpler way, or there's Territar or there's been a couple of suggestions for like collapsing this into one function, like Territar in the YouTube chat put this, and Jed made a suggestion of the absolute value function. So I think there are potentially simpler ways to do this, but this is the way that makes sense to me because it's very directly related to like the math that I was drawing on the board there. And to me, like this code is, I mean, it could be more readable, but this makes a lot more sense to me if I was someone else reading it. If I'm not the one who wrote it, then this does. So even though it's probably like not the best way, this is the way that I like, at least as someone who's in that experience of a programmer. Sounds good, Wolche. Yeah, I'm gonna switch away the screen, so if you want, like, take a screenshot of it, or I can maybe try to copy paste it into the Twitch chat. I'm not sure how pretty it'll look, but I hope this helps. Got the screenshot? Okay, nice. No worries. I'll keep this at the bottom in case I wanna, or in case we need to revisit it. Oh yeah, I see you joined the Discord too, so I'd be able to put in, I mean, you already have the screenshot, so it's fine. Okay. So, oh, Brian, yeah, you were testing the tech thing. Let's see if that works. Oh, hey. Okay, looks like it's working now. Let me try. The classic. Oh, I messed up the infinity. Yep, I think you have to type out infinity in tech, maybe. Let me try it. Just copy paste it. Let's not retype the entire thing. It's slash empty. Ah, okay. Thank you, Territar. Potentially takes as long as 15 seconds to update. Oh, I think maybe mine didn't go through because Nightbot was too quick for Nightbot. Okay, sweet. And now if I tried it over in the YouTube chat, it should work too. See, I've been trying to figure out a way to oh hey, cool, it worked. A way to like maybe try and display some LaTeX. I would rather have it like, yeah, it works for viewers too. So this way isn't perfect, but it is something. Yeah, that's thanks to a Noble Pit Painless over in the Twitch chat, aka Brain. So thank you again, Brain. So German sub TV, I have a linear operator t, which is defined as tx equals ax. Ooh. That's a little out of my knowledge. Let me copy it over to Twitch chat too, in case someone's around who might know what's going on with that question. Shoot, I'm sorry. I don't know how to do that one, German sub TV. I feel like there's people around who would know how, but they might not be here at the moment. But yeah, this is beyond the linear algebra that I know, if this is considered linear algebra. See, I'm sorry. If you want to stick around and see if someone like has a thought about that problem, feel free to. But I don't have a thought for it, unfortunately. Oh shoot. Well, Jay, if you're still here, I made a slight mistake in the code. I was making this time. It should be t though. Because I used my variable t as time mod period, so that there were two spots here where I should have used t instead of time. Oh, get rooked. Thank you for the follow and good name. Obi, someone in the YouTube chat put this question in. I have no idea how to do it, but that's kind of a got it. Okay, nice. Yeah, so some of that question in the YouTube chat, it's not in my expertise. I feel like people might know how to do it, but I couldn't quite, or I don't know where to even start with it, so. Oh no, the white background box is slightly, really? Is it too big, or is VS Code covering up some of the Twitch chat? I can't tell. Can we better? Okay. It will. I guess I need a little bit of downtime. We'll go back to doing this project Euler. Oh, the LaTeX is going to cover this up. Goodbye for now, LaTeX. Okay. So this code, it gets the wrong answer. Let me make sure that my slicing thing is doing what I want it to. Oh, God. Ah. 2, 3. Okay, that is doing what I want it to. Yeah, the reason I'm doing it is to try and prepare for the competition. How do you concatenate? Oh no, it's not like in Java where I can just do plus, is it? Oh, you can, no, you can't do plus. I have to convert it to a string? Ugh. Okay. There's probably a better way, but I'm doing it this way. Okay, so for example, we are excluding 2 to the 4th because it's the same thing as 4 squared. So is 4 squared getting double excluded? No? Is 16 to the 1 getting included? No, because 16... Wait, what? How come they only go as high as... This isn't right. I think I do want this to be starting from 0, now that I look at it. $17.57. That's way less of a number. Let's just try it though. $17.57. Nope, still wrong. Yeah, sure, critical. 100 to the 100 should not be excluded. Hmm. Okay. This is a very long string. Posted it? Okay. Compute the orthogonal projection of 1 minus 1 onto the line through minus 1, 2 in the origin? I've never done an orthogonal projection. Oh wait, is that just a projection vector? This phrasing on the line through this vector in the origin is a little bit weird, but if it's an orthogonal projection, it's like that one right there. Like, yeah. Oh, there's a dot product in here. Critical, does this type of formula look at all familiar to you? It does, okay. Then I bet we want to use this one. You know it as y hat? Okay. So we can just apply the formula here and see what happens. Projection. Well, orthogonal projection. I don't know. I don't know that's a different notation than the one I'm writing, but either way, It's these two dotted, it looks like. 1 minus 1 dot minus 1, 2 over that dotted with itself. And then I think, so this is a scalar multiple times the vector minus 1, 2, if I'm following the formula right. Yeah. So now we have a bunch of computations to do. So for a dot product, it's x times x plus y times y. So 1 times -1 plus -1 times 2 over x times x plus y times y minus 1 times -1 plus 2 times 2 times the vector 1, 2. Simplify all this. -1 minus 2 over 1 plus 4. This 2. So that's minus 3 over 5. It's minus 1, 2. Now bring the scalar. What the heck? Now bring the scalar multiple inside the vector here to get 3 over 5, comma, -6 over 5. So I think that's all the problem takes. How do I know which one is x? So the phrasing of the question is important. Okay, so in your format, is it like the projection of x onto y, like that with an x and a y? So I just want to know, like, what letters are you used to here? Or if you want, you can post a screenshot of the formula that you were given. We can use y like where I put it. So okay. This is something we have to look at the wording of the question. The projection of x onto y in words means that like x is the big one here and y is the small one down there, basically. Projection of x onto y. Like x is on top of y almost, I guess. I know that's kind of, it's kind of like a stupid way to remember it, but wait, 1 minus 1 is y? Oh, I'm sorry if I have it flipped. But post one more question, it's quite a lot. Okay. The vectors are orthonormal. No clue what orthonormal means. Oh, jeez. All just needs to be linearly independent. Oh, okay, orthonormal. That makes sense. These are a lot to check. By its determinant. Oh, that's linear dependence, though. Okay. I don't know if I would do two of these, but I'm trying to figure out like if there's a like a shortcut. Because I mean, I guess it's not so bad to do the dot product of each of the pairs of vectors. That proves orthogonality. And then you figure out if they're normal by getting the magnitude of each of these. Okay. Let's just go through the so it seems like an orthonormal. So it looks like the first thing we want to do is check if they're orthogonal. So we need to check if each pair of these vectors are at a 90-degree angle, basically. And the easiest way to do that is to see if the dot product is 0. Yeah, exactly that. And then the second step is to get the magnitudes of each of these vectors and see if they're 1 or not. The length of u squared. Why would we want the length of u squared? Oh, the magnitude of u squared. Isn't it just the magnitude of u? Well, I guess this isn't even all that helpful. Okay, I'm gonna put in the problem text, I guess, on the screen, and I'll copy down what the vectors are. It doesn't make a difference for 22. Or like, I had the same issue with 22, with whether it's magnitude of u squared or just, I mean, I can do 22 if you prefer. To me, there's not like a difference though. If you prefer 22, okay. And if it's like if it's not to be not so bad to do this one, then maybe we can do both. But if you feel like you understand the process, then it might not be much of a point in me like doing both. 4 over root 18. 1 over root 2. Minus 2/3, 1/3. No way that one's normalized, right? I don't know. We'd have to do some calculations to actually know. Problem is radicals. That's fair. So just to like kind of do the convention that you were using, I'm going to name these myself like UVW, just so we can kind of keep track of doing all the pairs here. It's not really necessary, but let's start by checking our dot products. So U dot V. So U dot V. Yeah, the radicals are pretty annoying here. We just have to jump in them though. So x times x, 1 over root 18 times 1 over root 2 plus 4 over root 18 times 0, y times y, and then z times z. 1 over root 18, 1 over root 2. Okay, so when you have a root times a root like that, you can group them underneath a big root and just do 18 times 2. 18 times 2 is 36. Anything times 0 is 0, so that goes away. Then we just have another... Oh, well, we get lucky on this one, right? Did I miss a negative sign? I did. Let me double check all my vectors now. I thought we were able to say they're not orthogonal off the bat, and that saves a ton of work, but okay. So there's a minus sign there, which means this is negative 1 over root 36, which is 0. All right, so u dot v passes. Let's try v dot w. V dot w, so 1 over root 2 times minus 2 over 3 plus 0 times 1/3 plus minus 1 over root 2 times minus 2 over 3. This is where it gets a little bit annoying with not having a radical here and here, but minus 2 over 3 root 2, that's 0. that's positive 2 over 3 root 2. So this one comes out to be 0 as well. I guess I wouldn't bother trying to like rationalize the denominators or doing too much simplification work. You can stop as soon as you see like a negative plus a positive of the same thing. It doesn't have to be fully simplified, is maybe the time-saving tip here. But it's still like just a lot of work here. So now for u dot w, meet chat. Okay. X times x minus 2 over 3 is 4 over root 18 times 1/3 plus 1 over root 18 times minus 2/3. Okay. So we have minus 2 over 3 root 18 plus 4 over 3 root 18 minus 2 over 3 root 18. So thankfully they all come out to have the same denominator, which makes these fractions a lot easier to compare. Negative 2 plus negative 2 is negative 4. Negative 4 plus 4 is 0. So I would just right there say that it's 0. So shown that all three of these are orthogonal. The next step is to check the normality. I'm sorry, I'm getting a knock on my door. I need to be right back. Okay, sorry about that. Critical, you're still here, right? Before I get too deep into it again. You are? Okay, good. Just want to make sure since I had left if you took a break. It would have been fine. I just wanted to check. Where can I write without? Actually, let me just get rid of that. We don't need that right now. Okay. So now let's check if they're normal. So now I get to analyze these one by one. So u. So is this the part maybe where you're getting caught up on the radicals? There's a little trick that we can do, at least for this one. Because I can definitely see how this gets a little annoying. But they all have the same radical in their denominator, so we can actually pull it out front. And we get 1, 4, 1. Now let's get the magnitude of this, and then at the end we can multiply it by 1 over root 18. And I think that'll make the computation a little bit easier. So the magnitude of u is equal to 1 over root 18 times the square root of each of these things squared and added. So 1 over root 18 times the square root 1 plus 16 plus 1. Oh, would you look at that? 1 over root 18 times root 18 is 1. So that vector is normal. So it doesn't always work if you have like a root 2 into root 3, then you're out of luck and you have to deal with the radicals. But if they all match up like that, you can pull it out first. So yeah, this one, let's look at, I guess, V. That's a tiny bracket. Do the same trick here. Pull out a 1 over root 2. 1, 0, minus 1. So the magnitude of V is 1 over root 2 times 1 squared plus 0 squared plus negative 1 squared. So 1 over root 2, that's 1 plus 1 is 2. So root 2 over root 2, we get 1. Also normal. W. Minus 2/3, 1/3, minus 2/3. We can actually do the same trick here. It's not a radical, but I think it'll still save us a little bit of work here. Minus 2, 1, minus 2. Four plus 1 plus 4 is 9. So we get 1/3 times 3 is 1. So yeah, I'd say these... the vectors are orthogonal and normal, so they're orthonormal. So yeah, and of course it only works if you do have the same denominator in all of them. Awesome. I see in 21 they do throw, that first one has a different denominator, so there'll still be a little bit of work involved there, but if the trick works, it does make things a bit simpler. So I mean, if you want to see 21, I'll do it too, but I guess you tell me if you want it. 20 is okay? Okay. That's not what I want. There we go. Okay, time to interpret. Oh. Yeah. Those numbers are just a little too big for me. Actually, let's say 10. Well, we don't know the expected, well, we don't know the expected number for 100 either. Because, oh, Like right here, we're improperly excluding 4 squared. Why would it want to do 16 squared? It should be excluding because of 16 to the 1. Hey, Zach, thank you. Yeah, 900 followers on Twitch. And on YouTube, I'm really close to 600 subs. Where are we at right now? 598. YouTube subs are catching up. Oh, okay. Just saw my minority suspect put a got back to me on a problem that I worked on offline. Let me bring it up. So minority had this related rates problem, and I got the same answer as what they got. So what is this? This was minus 220 times e to the negative 8. Let's plug that into Wolfram. I'll bring up the original problem here while I plug it into Wolfram. Hmm, 15 times 8 is that, right? Oh, it's 120. Oops. So 15 times 8 times e to the negative 8, the negative sign in front, is minus 0.04. And this is supposed to be minus 3.25? How does that work? I feel like they're... Okay, let me actually Google the problem. Rectangle shown in the figure. Find the area of the rectangle as a x e to the minus x squared over 2. Let's see if I can find an answer and I'll switch over. Nope. You're back, but gotta go? Okay, well, assuming you're taking your final, good luck with it. Your final's gonna be terrible. Nah, dude, you've been working so hard on this. I'm sure you'll do great. Chemistry and algebra for 8-week courses. That does make it harder, but algebra during the normal semester. I mean, just give it your best go. That's it. That's all you can do. Hey, $10. Okay, this dude on YouTube solved a similar looking problem. Let's see if he does anything different. All right, bye, critical. See if the derivative matches. Oh yeah, okay, so this is we're taking the derivative with respect to time. So ours looks slightly different. But the overall form should be similar. And it looks like it is. Opposite signs in x squared. Oh, wait. Hmm. Yeah, I don't know if you were able to read the initial problem, like, or I can show it to you again. So could it be? I mean, I feel like we accounted for that by the how we set up the formula for the area. I get the same answer as minority suspect does here. So that's the original problem. Then I'll switch it over to minority suspect's work because I didn't get anything substantially different when I did it my way. So yeah, area, it's twice of x times the function, which is the height. Then you take the derivative with respect to time, which area is a function of time and x is a function of time, so it's implicit differentiation. Minority suspect factors out the 2 in front, which is completely fine. In this answer, it's like way off of minus 3.25. This is like minus 0.0 something. Cool. Yeah, you do the product rule on this thing. Minority suspect kept that x the same and took the derivative of the e to the negative x squared over 2 first, which comes out to be just the original thing times the negative x because of the chain rule, then times dx by dt because we took the derivative of an x with respect to time. And then for the second part of the product rule, we're supposed to derive the x, which went to 1, times dx dt, and the original thing transfers down. Yeah, I really don't see the issue here. Hey, Aben Sobi, can I solve tangent to the fourth of x or tangent of 4x? But either way, is it equal to 0 or like what is it equal to? Tangent is supposed to be minus 3.25. Hey, Stooky, how are you? But this is like minus 0.0 something here. So going strong? Yep, you know it. We're going weak because apparently I don't know how to do this calc 1 optimization problem, or there's a typo in the original text, but or not optimization, just related rates. Okay, I'm gonna plug in the numbers again. Just, I don't know. Okay, I have them here. Yeah, it's minus 0.0402. If you plug in minority suspects last line into Wolfram. And the only homework, or the only like answers I can see are like, you know, Chegg and like the sites that make you pay to see the answer, so. Like, is there something we could easily modify the problem to make it work? All right, I'm not sure exactly what to do with this problem, but I see that Abe and Sobi over on YouTube posted a question. Hey, Phobos. How's it going? So, Abe, it looks like we're just applying, so is that tangent, oh wait, tangent of 4x there. So, I got a feeling that we're applying this identity twice. And I assume the task is to prove this identity. Do I spy a wild Ian Stooky? I think you do. Okay. A wild Ian Stooky appeared. Ah. Pokey catch Ultra Ball. Put a question mark because that's what we're trying to prove. 1 minus tangent squared x over 1 minus 6 tangent squared plus tangent to the fourth. All right. There's going to be a lot of algebra in our future, but that's okay. In our disposal, we have the double angle identity for tangent, which is tangent of 2x is 2 tangent x 1 minus tan squared x. It's not how you spell tangent. Hey, JE Studio. Oh, I don't know. That'll be an interesting summation. I don't know. I don't know off the top of my head how to approach that, but I'm working on this problem first. I forgot something, Fenbuck says. Tangent of 4x, 4. Oh, you're right. Thank you. That a squared? 4 tan x, 1 minus tan squared x. Okay. I think I have a copy down right now. Okay, and even saw the same thing. Okay, so can we be sneaky? Is there a factoring thing we can do here? No. Okay, no sneakiness. Well, ooh. I think there's a sneaky way to work from the right-hand side. I think it's more direct if we start from the left, but okay, I think if you factor the bottom, you might be able to do it in reverse, and it might actually be a little bit simpler, but let's do it the more direct way of applying the double angle to the left side. So tangent of 4x is equal to, now we're going to use this, but substitute like 4x, so that'll be 2x and 2x. 2 tan 2x over 1 minus tan squared 2x. And now each of these will get double angled, and that's where things get really fun, depending on your definition of fun. 2 times 2 tan x over 1 minus tan squared x over 1 minus 2 tan x over 1 minus tan squared x squared. Sloppy x's, but okay. And now hopefully we clean this thing up, and hopefully it matches that. All right, well, 2 times 2 tan x is the 4 tan x on top that we desire. This 1 minus tan squared x, we can transfer it down to the denominator. So 1 minus tan squared, this 1 minus tan squared x is this 1 minus tan squared x. All I did was bring it down to the bottom. And then times the original bit here. And I'm going to bring the squared inside the parentheses. 4 tan squared x over 1 minus tan squared x squared. I'm not going to multiply this out quite yet because we might not have to. Okay. Well, that's annoying. I want to get rid of that denominator there. We can do it a little bit by multiplying in the 1 minus... Okay, so we can take this 1 minus tangent squared and multiply it with the 1 and multiply it with that bit there. And that'll get rid of one of the powers of 1 minus tangent squared, at least. So we get 4 tan x over this bit times 1 is the same thing. And then here times here. But this will cancel with one of the powers of that. So 4 tan squared x over 1 minus tan squared x. Okay. And now we can get rid of this denominator by multiplying the top, by multiplying it by 1 minus tan squared x over 1 minus tan squared x. Like, fancy one. Okay, so in the numerator, we get this times that, and the numerator is actually set now. It's exactly where we want it. The denominator, I'm going to take this times that to make it squared. We're able to do that, right? Yeah. No. Yes, we are. It might be better not to do that, though. Nah, I'm trying to save work, but it's not really going to save work. I'm going to take 1 minus tan squared times 1. And then 1 minus tan squared times negative tangent squared. So negative tangent squared times 1 is negative tangent squared. Negative tangent squared times negative tangent squared is plus tangent to the 4th. And now I take that term times that term, and they just cancel. So all we end up with is minus 4 tan squared. Oh, and look at that. We have a 1. Minus tan squared minus 4 tan squared is minus 6 tan squared. And then we have a plus tangent to the 4th. So we started with tangent of 4x, and we managed to make our way to the end result here that they wanted, so I'd say that we've proven it. Does that make sense, Aben? Do you have any questions about what I did? No worries. Okay, so JEE Studio, if you are still here, you put in a question that gives me a little bit of a scare, but let's see if we can figure it out. I assume there's a typo in this. I assume it's going to be 1 to the 1 plus 2 squared plus 3 cubed, like that maybe. That's not easy to figure out, is it? Akshat says 3 to the power x is equal to x to the power 9? Really? Oops, to the x to the 9. Okay, no. I don't think, I wasn't misunderstanding you, Akshat. I don't think that's true. This being like maybe right at that one point where they intersect. Oh no, it's probably an irrational number. Is this in? I should probably Google it because it does seem like of n to the n. Oh, I don't even. Yeah. I haven't seen JE Studio type since putting that problem in chat either, so I might tactically move on. Because I don't even know like where to get started on this. Why is ZQ is not a vector space where P is not equal to Q and PQ are two prime numbers? Ooh. I don't know that type of math, Mr. Debnath, I'm sorry. Like linear algebra / abstract algebra? Oh, Akshat, you're putting in your own problem you'd like to solve where 3 to the x is equal to x to the 9. I definitely don't know how you do that either. Yeah, Mr. Debnath, I haven't studied linear algebra that deeply. Okay. So it's with respect to what minority suspect. I really can't find the error here. I wonder if there's a typo in the answer key. Because I get the same exact answer, but the answer key says it's wrong, and I just can't see where or how. Oh, is there something new in here? Oh gosh. From Stooky? Newtonian integration and Riemann integration. I haven't heard of Newtonian integration. Let me, before I look too deeply at Stuckey's problem, let me, Newtonian integration. Don't see. I mean, I don't know what a Newtonian integral is either. But yeah, I'm just gonna switch to looking at Ian Stuckey's problems. I'm not sure what to make of that. It seems the median of the trapezoid is the line connecting the points of two non-parallel sides. The question is, what is the length of WK? It seems the median trapezoid is the line segment connecting the midpoints of the two non-parallel sides. Okay. As written, the problem is undetermined, but it should be determined if we assume that DA is longer than CH, as we couldn't have the purple line that I drew in. Okay. It's from a high school geometry course. I suppose the bonus question is to do it without trig. Okay. Ugh. Chad. Hell yeah. I love when trapezoids, or when like shapes have a name. CH is 12, HK is 9, WD is 7. The measure of angle D is 73. And just, we're given a median WK. Find the measures of the following. Okay, well, Sui's question is what is the length of WK here? The midpoints of the two yeah. So I guess this KA would be 9 as well. Oh, and Stuckey made an isosceles triangle there. For part of this, and then also maybe a parallel side of the same length to CD. What the hell? Now, I'm just going to try it, but I assume that at some point we tried Googling median of a trapezoid. The answer is 27? How did you get that, Akshat? You did not do that. Oh, Google the median of chat. Oh, okay. The legs of a trapezoid, I guess, are the non-parallel sides. Okay, so yeah, we do know that it bisects each of those. Okay. Oh, I'm sorry, Akshat. Yeah. I'm not too good with solving those types of problems. Length of the median is the average of the bases. So length of the median is AB plus CD over 2? Oh. Oh, but we don't know... Okay, but the issue is we don't know dA in the problem that we're given. Can we work out what dA should be? Hmm. Do we know with this? I guess I mentioned this like extra line of length 7. Does that form a parallelogram? It's like, would this D up to that line of length 7 also be 12? And then we somehow law of cosines our way around with the triangle that's formed by the 7, the 18, and this unknown length. We can work out what an angle of this is. So I think the law of cosines is in the realm of a geometry class. It's parallel to the 73. So that's also a 73 angle. Okay, let's go to the whiteboard, I guess. So you had in mind with the pencil line? Okay. Slide it over there. Oh. So yeah, that parallelogram seems to be a good idea. Well, just say the entire thing is 14. Okay, and that was, oops. I guess I'll call that point E. So if we log cosines on that angle, it'll be 18 squared is equal to 14 squared plus EA squared. It's in the game. Minus 2 times 14 times EA cosine 73 degrees. That's work for a calculator, but you could do that. So was there an issue? I guess maybe it's something you thought of the same approach, Stuki. So was there something you didn't like about that? That's your exact result, Wolfram? It's a terrible last result. Or the exact result, not last result. Okay. Let me see if I can put along. Product of roots and sum of roots. That's not... Okay. Ralph, you are annoying sometimes, you know that? Yeah, I'm gonna make Wolfram do the quadratic formula whether it likes or not, Teratar. Just make it do the calculations in steps, I guess. 28. Okay, so that's our quadratic. So now off to the right here, let's write out the quadratic formula. Minus 28 times cosine, 28 cosine 73. I assume we're gonna take the plus. Square root b squared 28 cosine 73 squared minus 4 times a is 1, c is 128. Great call, Stuki. So just put a negative sign in front. Flip that thing to plus. That closes the square root. Put the entire thing in parentheses and divide it by 2. Take that input, bring it over here. 7.93, unless you want the exact form right there. Or 7.94, I guess. So the other part of the segment was 12, so 19.94 would be the entire length. I don't know. Is that what you were looking for, Suki, or are you looking for like a different way still? So I might be able to like at Jed, because he likes geometry, and see if he has a different idea. That seems fine? All right, sounds good. That is an annoying quadratic to have to solve, though. I hope that, you know, the calculator's allowed for that. Thanks for the question. Oh, and then I guess WK is the average, but that's easy. Yeah. Okay. It says 19. She came out of that 7. I guess so, yeah. Oh, like the 12 plus the 7? Yeah. That's a weird rounding if I said it's 19, but they probably didn't use like Orthonormality to do the entire problem at once. All right, so I'm planning to go for a couple more minutes because I think complex variables should be starting up soon. It's really annoying to me that I haven't. I thought this problem would be kind of short when I chose it. I mean, it really is short. I just am making it long because I insist on doing it this way instead of the brute force way. You know, let's just brute force it. Python has sets, right? Oh, but you can't append. Unordered, unchecked. I mean, I can still use a list and just check if it's in there. So I want to answer this thing today. Oops, not that. For I in range a min, a max plus 1. For j in range a b min, b max plus 1. I do need to keep a nums equals brackets. If not I to the j in nums dot append I to the j. Print length nums. That's like all you actually have to do for the brute force way. 9183. Like, if they gave you a million, this probably would take a long time. But I wanted like a more refined way, I guess. There we go. Two seconds if I just suck it up and do it the easy way. It does look like Pen Center is live. Oh no, but Pen Center's lagging. Oh. We're probably still gonna raid Pen Center anyway. Oh shoot, yeah, I can't even check it now because the ads are going. Let's raid Pen Center anyway. So I hope the stream doesn't completely crash, but I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you. I'll be back on YouTube on Saturday, starting up with physics, and then oh shoot, he's restarting the stream. All right. Anyway, I'm gonna have the YouTube stream here. So yeah, Territory, I'll see you around. Anyone else is here on YouTube, thank you. I'll see you.